Thank you very much. I appreciate that. And I appreciate all of you being here. You're all doing something to push back on the climate crisis. And that is very important. 440 million years ago, the world is a very different place. Life is confined mostly to the seas and dominated by strange creatures like sea scorpions the size of a human, and weird primitive fishes, and multitudinous trilobites, and cephalopods that lived in large conical shells. Now, if you were there back then, you might have thought, well, this is it. This is how life is always going to be. After all, these life forms had been like this for millions of years. But the continents, they were drifting. And as they drifted south, the climate began to cool, and the snow and ice began to accumulate, drying out the shallow seas and causing the first mass extinction since there's been complex life on Earth in a climate crisis that wipes out 85% of species. But life rebounds in the Devonian and Silurian periods. The first forests appear on lands. Our Sarcopterygian fish ancestors, they climb out from the seas with the newly evolved limbs. But again, there's a climate crisis. It's a combination of bad ocean chemistry and bad atmospheric chemistry, and it causes the second mass extinction, in which we lose 75% of species. But life, as they say, finds a way. And in the Carboniferous periods, the first real massive forests begin to cover the continents. The first coal swamps form. We get reptiles, and the world starts to become a little bit recognizable to the world that we have today. But those continents, they are still drifting, and they all bump together about 250 million years ago, forming the supercontinent of Pangaea. And on large continents, climates are extreme, and it's also hard on life, because when everything is in contact with everything else, everything has to compete with everything else. And then the Earth itself opens up. In what is now Siberia, large volcanic fissures issue forth immense quantities of CO2, of greenhouse gas. And the atmosphere overheats, and we have the world's worst mass extinction ever. We lose 90% of species. We lose 70% of species in the ocean, 96% of species on land in what we call the Great Dying. Complex life on planet Earth almost goes out of business at this point. And then we enter the Triassic period, this depauperate post-apocalyptic world, and that is when the dinosaurs first evolve into this really terrible world. But those volcanic fissures are still active. They're still belching greenhouse gases, causing another mass extinction, the end of the Triassic, and we lose another 5%, 75% of species. And then the world of the dinosaurs really begins in earnest in the Jurassic period. And dinosaurs evolved to get huge, and they spread out on all the continents, and they become the dominant forms of life on land. They all live on land for 165 million years. And when paleontologists first discovered dinosaurs around the middle part of the 19th century, well, they could see that they were here for some interval, they persisted for some time, and then poof, they were gone. And nobody had any idea why. And humans did what humans do when we don't know something. They made stuff up, right? And so there were all these published, now, crazy crackpot ideas about what had happened to the dinosaurs. For example, maybe sex determination, like it is in crocodiles, was temperature dependent, and it got too hot to make males or too cold to make females. Or maybe our little shrew-like forebears, maybe us sneaky mammals, maybe we ate all their eggs. Or maybe, and this was a prevalent idea in the 19th century, maybe they were just too dumb to live. This was an idea called species senescence. Maybe a species after time just kind of runs down like a human body does, and maybe eventually they perished of their indolent nature and their failure to adapt. Or perhaps, and this is my favorite, perhaps caterpillars ate all the fiber-rich plants, and the dinosaurs, they perished of constipation. Published paper. And then in 1980, another seemingly crazy hypothesis was published. The paper title was An Extraterrestrial Cause for the Extinction of the Dinosaurs. And extraterrestrial made it sound a little bit wacky, right? But this was based on hard science. It was published by Walter and Louise Alvarez, who were working on Cretaceous beds in Gubbio, Italy. They saw that clay layer that Walter has his hands on there. They did an elemental analysis of its composition. They found that it was high in the element iridium, which they knew is very rare in the crust of the Earth, but very common in asteroids and comets. So they proposed then that it was an asteroid, and we know now it was an asteroid or a comet that took out the dinosaurs. And so a worldwide search starts for this extinction layer. And the layer itself from the fallout alone has been found in over 350 spots around the world. But precious few fossils have ever been found in that layer. In Poland, there's a mosasaur vertebra and a single tooth. In Missouri, there's a similar occurrence. In Belgium, there's some fish scales. And now in North Dakota, there's a pile of paddlefish and a single dinosaur leg. And I myself began to search for the fossils in this layer, and I looked in North Africa, and I looked in Patagonia, where I discovered Dreadnoughtus and spent over a year of my life living in a tent. And I looked in the Gobi Desert, and in the foothills in the Himalayas, and in Montana and Wyoming. And finally, I found what I was looking for in this quarry behind a shopping center in New Jersey. A place where now me and my crew have been excavating very methodically for the last 13 years. And in that time, we've only processed about 220 square meters of this fossil bed. That's roughly the size of this room. And in that space, we have cataloged over 100,000 fossils, representing over 100 species from the very last moments of the dinosaurs. And so now we know a lot about the actual event, largely from a drilling project that happened a few years ago off the coast of Mexico, drilling through the actual impact crater. So we know that the impact probably happened in the springtime because those fish in North Dakota had spring pollen trapped in their gills. We know that the asteroid was about an 18-kilometer carbonaceous chondrite that came in from the northeast at an angle of about 52 degrees, and it makes a 180-kilometer crater, about 110 miles, in the Earth's crust. Now, at our site in New Jersey, you would not have known anything was amiss at the time of the impact. You wouldn't have seen the asteroid flying overhead. It would still have been in space when it crossed over the North Atlantic. You wouldn't see the fireball. You had to be within 900 miles to see that. But then in New Jersey, at about 17 minutes later, the sky falls. So imagine all that rock, it's about the size of Massachusetts by 12 miles deep, blasted into the atmosphere. Imagine what Massachusetts weighs, right? Giving that mass a tremendous amount of potential gravitational energy. It's pulverized into maybe millimeter pieces, but it still has that mass. That material goes into space. When it comes back in, it has to balance the energy books. And how does it do that? Well, by heating up the atmosphere. Imagine that day, trillions upon trillions of tiny millimeter-sized space capsules, each one flaming back into the atmosphere, each one heating up a little parcel of air around itself, so that that day, temperatures get up to somewhere between toaster oven and pizza oven. So if you were on the surface of planet Earth that day and do not have shelter, like a hole or a cave, then you perish. And the dinosaurs that dominated Earth's terrestrial ecosystems for 165 million years would not see one day more. And in fact, at the site in New Jersey, they would not see 1 hour more. And then, after about 2 hours, hurricane force, hot air blasts ripped through the area, knocking down about 90% of the trees. And then sometime later that day or that evening, a tsunami, a 42-meter wall of water breaks on the coast, grabbing the broken trees and the downed landslides and the barbecued dinosaur bodies and hauling them out to sea, where they settle at our site. Following that, the Earth is shrouded in dust and gas, and we go into an asteroid winter, a prolonged period where photosynthesis is cut back to next to nothing. And this precipitates now a second parallel mass extinction in the ocean. On the land, you die mostly that day because of the heat. In the ocean, now with the base of the marine food chain kicked out, that starts to rapidly propagate its way up the food chain. The ocean food chain is only about 2 or 3 weeks long. And then the world can no longer support the insatiable gluttony of sea monsters like mosasaurs and plesiosaurs. And the result is that we lose 75% of species on Earth in an instant, really. And so that is the world's 5th mass extinction in which the dinosaurs perish, really paving the way for the modern world as we know it. So the site that we have in New Jersey, we know now that it is scientifically important. We think that it is a place worth preserving and a story worth telling. There was a plan when I started working here for the mining company. They were going out of business. There's a closeout plan. They were going to fill in the quarry and build some big box stores there. And I thought, what a terrible shame it would be to lose really this site of world heritage. So I began to work with the community to try to save the site. And that was about 13 years ago. And eventually, I raised enough money to kick off the project. These two lovely individuals there on your right, Gene and Rick Edelman, made a substantial contribution to the project to get us going. And this is us a year ago, November, groundbreaking on the museum that we are now building on this site. We bought the property. We're building a 44,000 square foot museum there. The building itself is a $73 million project. The entire project is $85 million, including a new roadway and 2 new bridges into the site. This is an artist's rendering of what it will look like. You can see it sits there between the active fossil quarry, the old quarry, which is now a pond, and you can see off to your right there, your left there, there's a paleontology themed playground that will be there as well, along with exhibit galleries, a theater, cafe, all the things that you would expect. It's going to be a very beautiful building. This is the artist's rendering. This is a picture that I took 2 days ago. So it's happening. That blue is the waterproofing. The wood cladding goes over top of that. We're not building an IKEA there. It's, this is from the lakeside, artist rendering, and 2 days ago. Yeah. Thank you. Now, there are a lot of things that I just love about this project. The first is that the museum has been designed in a very sensible way. We are taking advantage of ground massing. A good part of the lower floor is underground. Building massing, right? So we have a lot of thermal inertia, as well as the orientation of the building. And we will have geothermal energy. We will have solar energy, so that when we open the doors next year, we will be New Jersey's largest carbon net zero facility. And my second favorite thing, well, maybe my first favorite thing, the other thing, is that above that fossil layer that obviously we manage and curate very carefully, there are layers of sediment from just after the last moments of the dinosaurs that are still full of fossils. But those fossils aren't particularly scientifically important, so we can let the public come in and collect from those layers. And every kid, every grown-up, anybody who goes there and who's not afraid to get their hands dirty and who tries a little bit finds a 66-million-year-old fossil with their own hands that we let them take home. And that becomes just a transformational moment when people make that connection between themselves and the Earth's ancient past, when they start to see themselves as part of this long tapestry that has been Earth history. And I can tell you that the children that go here, they really get it. They get the authenticity of it. I've had parents tell me that we offered to take our kids to Disney World on spring break, but they said no. They want to go to the Edelman Fossil Park, sorry, Florida, because it's real, right? It's authentic. And they become authentic explorers, because when you find a fossil, you're the first human to ever see that. And what are fossils in our field of science? Well, they're packets of information. So you become the first human to ever know something. It's an authentic discovery. You become an authentic explorer, and it's addicting. And it becomes part of the process of us then inculcating them with the scientific method, which is a way to receive and process information in a rational way. And boy, we could use some of that today, right? We have our 5 mass extinctions, and now that brings us close to the present. Humans are not in that picture, right? That whole story I told of Earth history, no humans in that at this point. We have our forebears, right? Fish and reptiles and eventually mammals. Humans don't enter the picture as even Australopithecus, right? You know, Lucy. That's about 6 million years ago. That's 0.13% of Earth history ago. If Earth history were a 1,000-page book, that's on the last page of the book. And then there's Lucy. And then our own species, Homo sapiens, appears only 300,000 years ago, 0.006% of Earth history ago. In that 1,000-page book, that would be on the last line of the book. And then civilization, really the last 10,000 years, well, that just happened. And really that happened because of a climate accident, that the climate hit this really stable period. You know, we had the same brains that we have now 300,000 years ago, but there was no farming, there were no cities, there were no farms or cities 100,000 years ago or 50,000 years ago. Why is that? Because the climate was swinging wildly up and down in this glacial and interglacial cycle. And then it got stable about 10,000 years ago, and humans could stay in one spot, and they could put down roots, and they could farm, and they could build a building that they're going to use this year and next year. And all that happens 0.0002% of Earth history ago. We humans, we just got here. And in that tiny interval of time, it's the last word in the 1,000-page book. That's when all the history you've ever heard of happens. All the generals, all the kings, all the queens, all the armies, the battles, all the poets, the writers, they all happen in that little tiny interval of time. So why do we study the ancient past? Well, you wouldn't want to understand a book, would you, by just reading the last line of the story, right? We study the ancient past because that's where the answers are. We study the ancient past because that's where the data lie. And if you take the time to learn to understand the language of the rocks, they will start to talk back to you. And wherever you go in the world, they will say the same thing. They begin to whisper to you. And they say, it didn't have to be this way. It didn't have to be this particular way, because at any point in history, there are an infinite number of futures that we could have had, right? Nudge a space rock there. Reorder an event here. A single sunbeam causing a single mutation is all that it takes to change the course of all that is yet to be. It's all so contingent. And we have been the beneficiaries of this amazing stack of past futures that led to this very particular moment. And what are we doing now? We're using the atmosphere as a garbage can. In the last 800,000 years, atmospheric CO2 has never breached 300 parts per million. Not when the common ancestor of Homo sapiens and Neanderthals existed, not when we split from our kin, not when Neanderthals went extinct some 50,000 years ago, not when this country was founded. But now here is what is happening. That's not a mistake in my chart. That's the brick wall that we are all facing. And that is having devastating consequences on the biosphere. The United Nations estimates that a species on planet Earth goes extinct once every 20 minutes. During this talk, it is probable that a species that has an unbroken chain of ancestry back to its 3.8 billion year old microbial forebears will go extinct. A lineage that survived the first, second, third, fourth, and fifth mass extinction, but cannot survive us. If you look at the background rate of large creatures, the extinction of large creatures over the last 2 million years, the background rate is that we lose an average of about 9 vertebrate species per century. Well, in the last century, we've lost 9 species, plus these, and these. We are propagating the world's 6th mass extinction. And we know now through geology and paleontology that the previous 5 were all caused by climate crises. The last one, a climate crisis induced by an asteroid impact. Well, now we are the asteroid. But we don't have to be. There's still time to act to avoid the worst of it. Will we listen to the urgent dispatches in the fossil record that tell us that we are not the recipients of some cosmic proclamation of manifest destiny? We got lucky. Will we listen to the whispered warnings of the rocks that tell us that the Earth does not need us? Far from it. The Earth has mostly not had us, but that we need the Earth. There is no planet B. There's not going to be a planet B. All we have, and all we will ever have, to guide our way into the future is each other and the past. What's next is up to us. Thank you.
Thank you.
I'd be happy to take some questions if you have them. Or comments, yeah.
How did you arrive to find this New Jersey site?
Well, the question is, how did I arrive to know at this site in New Jersey? I began going there in 2003. At the time, I was a professor at Drexel University. I'm Dean of Earth and Environment at Rowan now in New Jersey. It was a mining company. I would take my students there so they could collect some fossils. We were doing what we would call salvage excavation, literally just following the bulldozers and not able to really set up shop and get the context on the situation. And really, I didn't think much of the site. And I would literally drive by this site on my way to the airport to fly to Patagonia or the Gobi Desert or the Sahara and all those other places. And then when the company started to go out of business, first I rented the site for 2 years. And then when we could stabilize it and set up our grid and start to excavate properly, then I started to see what was possibly there. And honestly, I wouldn't let myself believe it because the chances of finding a particular day in Earth history, like a Thursday, right, are pretty remote. So I have to say that the realization of the significance of this place dawned on me embarrassingly slowly, right? But eventually I got it. Yeah, thank you.
Where is it in New Jersey?
It's in southern New Jersey in Mantua Township. It's about 20 minutes southeast of Philadelphia. If you flew a drone up from the site, you can see the Philadelphia airport. The Fossil Park Museum, we are planning to open spring break of 24. So that will be late March, early April. We don't have the exact date nailed down yet. The building will be finished in the fall and the exhibits installed then. The roadway is the last piece of the puzzle. And then next winter, we'll have some soft opening events to train the staff and see what's working and what's not. And then we'll open in the early spring. Yeah. Yes, sir.
From a funding standpoint, how did you make the jump from a college class project from what I heard you say, to the large undertaking that it is now? I mean, how did that come about?
Yeah, well, one of the things in paleontology is you learn to become very entrepreneurial, right? Everybody loves dinosaurs, but NSF doesn't necessarily want to fund dinosaurs. So, while I've had my share of NSF grants in my career, I funded a lot of my expeditions from philanthropy and actually a lot of them from film companies who would pay to have us go and they'd make documentaries. So I was in that world, and so I began raising money for the fossil park. Rick and Jean Edelman stepped up, and their first contribution was $25 million, which was a very nice start for us. They came back and made additional contributions since then. Other people joined in. We have some funds from the State Transportation Trust Fund to build the road and the bridges, and so we've been piecing it together from various sources. There are avian dinosaurs with us today. What are avian dinosaurs? Wow, this is quite an audience. I usually take about 20 minutes to explain that to an audience, I I tell teachers when I speak to schools that when I tell them that a little fuzzy penguin is a dinosaur, there's going to be an uproar and you're going to have to step in to quiet the crowd, right? So yes, avian dinosaurs are birds. What we know is that for the non-avian dinosaurs, like regular dinosaurs, right, all of the nests that paleontologists have ever found, all the egg nests, are just a crater that some mama dinosaur scraped in the ground where she deposited her eggs right on the surface of the earth. So for non-avian dinosaurs, they seem to have had 100% of their life cycle on the surface of the earth. The only dinosaurs that we know for sure were burrowers are birds, right? There's burrowing parrots, there's burrowing owls, swallows, lots of different birds will burrow into an outcrop to lay their eggs. They're the ones that get through. Who else gets through? Little burrowers, little mammals, crocodiles, turtles, lizards, things like that. This is all radiated heat, so you have to be line of sight. If you can get some shelter, even 6 inches of sand, you're probably okay that day. You might not survive in this terrible world that you emerge out into, but you're not going to cook that day if you can get just a little bit of shelter, which all the big dinosaurs could not do. Yes, ma'am.
This is going to sound really far out there. Since you use the past to help see into the future, do you think humans might evolve back into the ocean once we screw up the Earth? I mean, it's a lot easier to get to the bottom of the ocean than it is to get to Mars.
Yeah, question is, do you think humans might evolve back into the ocean? And so there are lots of examples in Earth history of creatures evolving onto land and then evolving back into the oceans, right? That's what whales did, and manatees did. The thing about evolution is evolution has no inertia, right? It has no trajectory. Evolution is only about what's happening exactly now today and what portion of the population is slightly more reproductively successful than another portion of the population. That's all. So there's no prospection with evolution, right? We could think of all kinds of things that it would be great to have, like eyes in the back of our head, but there's nothing to drive that force in that direction. It's all about what's happening in the moment. So no one knows. Yeah. Yes, sir.
Yes. I hate to tell you this, kind of tell you my age, but 50 years ago, I was going through graduate school at the University of Cincinnati and Ohio State in environmental engineering. We learned about global warming there. I had professors both at University of Cincinnati and Ohio State that talked about the principles and the concepts of global warming. And I've been following it ever since. I'm to the point where I'm pretty pessimistic that we've hit the tipping point, as Malcolm Gladwell so wrote a book about, and that we've got to start preparing for the consequences, how we're going to deal with the consequences of global warming. And there's a very interesting article in Scientific American November about the glaciers. There's a glacier down there that's melting faster than anticipated. And within 10 years, we're going to have 2 feet of water or ocean level. So I just wonder, what you think as far as the possibility, of mitigating what we've got in motion. Momentum is an engineering term, but it's a terrible force.
Yeah, I appreciate that question. And, first I would say it's not an either or, it's a yes and, right? So yes, we have to prepare for the worst effects of planetary overheating. But at the same time, we have to do everything we can to arrest those processes, right? And to stop them and eventually reverse them. So we have to do both of those things. As far as hope, I can't stand here and tell you that I have empirically derived hope. I believe that hope is a choice, right? And I choose to live a hopeful life because I'm afraid of what would happen if I didn't, right? And so I think it's incumbent upon all of us to do the hardest thing that you can do as an individual, the hardest thing that you can do with your accumulated talents and resources. I know for me, there's a lot of days when I wake up in the last few years, building a museum is absolutely the hardest thing that I can do. It's really complicated. But whatever that is, I think we're at the point where we all need to do that thing. I'd rather be in a desert somewhere digging up some big, dumb dinosaur. But I'm not sure that I have that luxury right now. I think I have to do what I can do right now. And also, you use the term global warming. I would just like to gently suggest that maybe we need better terminology. I think global warming, climate change are really propaganda, in some cases sponsored by the petroleum companies. I mean, warming sounds kind of nice. Who doesn't like to be warm? That's why you all moved to Florida, right? And change, climate change, I mean, people usually think of change as good, and change could be good or bad, right? I mean, let's call it what it is. Let's call it a climate crisis. Let's call it planetary overheating. Let's call it the sixth extinction. Let's call it a biodiversity crisis. We need the appropriate terms for the dire situation in which we find ourselves.
Ken, thank you so much.
My pleasure.